Okay, so in this lesson, again, we're talking about radicals, and this is part 3. This time, though, we're going to assume that all the variables represent any real number, whether it's positive, negative, or 0. In the previous lesson, the 2 lessons, we assumed that they were non-negative, meaning that they were either positive or 0. That's what we assumed, and so we didn't really discuss that at that point. Because it wasn't really necessary. Now it's going to be necessary. So before we do that, and before we really get into it, let's kind of review something for a moment. Okay, so suppose I want to simplify this radical, and let's say the radical is the square root of, let's say, x to the 6th power. All right, let's suppose it's that. All right. Now, when you simplify that, the square root of x to the 6th, based on what we talked about before, that's going to be x cubed. Okay? So, technically, what this is saying is that these two things are equivalent, because I'm saying that the square root of x to the 6th is equal to x cubed. That's what I'm saying. All right, so let's look at this. In the previous lesson, we said assume that the variables were positive or 0. So, for example, if x equals 2, if x equals 2, let's see what what the left side equals and what the right side equals. Now, you're going to need a calculator for this, so make sure you're using your calculator. So we're going to let x equal 2, and we're going to see if that's actually true. If x equals 2, is this going to equal this? Okay, so we're going to have, let me actually do this, if x equals 2. So we have the square root of 2 to the 6th, and I want to see if that's going to equal 2 to the 3rd power. That's what I'm asking. So in place of x, I'm going to plug in 2. Well, 2 to the 6th here, so if I use a calculator, I'm saying 2 to the 6th, so 2, oops, turn it on, so 2 raised to the 6th power equals 64. So that's the square root of 64. It's right here. And we know that the square root of 64 is equal to 8. Yeah. And then here, 2 to the 3rd power, we really don't need a calculator. You know that's also equal to 8. So these two are equal. All right, so when x equals 2, this expression equals this expression. That's what you just saw. All right. So is it true for x equal 5? Is it true for any positive number? All right, so that's the idea. Is it true for any positive number? Well, let's suppose x is 5. Let's see what happens. So if x is 5, I'm going to go ahead and again check and see if this expression equals this. So is the square root of 5 to the 6th power going to equal 5 to the 3rd power? That's the question. Well, using your calculator, this is the square root of 5 to the 6th, so 5 to the 6th power, and this would be a big number, so 5 raised to the 6th power is 15,625. So 15,625, I'm taking the square root of that, so the square root of that, 15,625, equals 125. So that's what that equals. And so 5 cubed, if you use your calculator, 5 raised to the 3rd power, 5 cubed, you get 125 as well. All right. So when x is 5, this expression equals this expression. So it turns out that when x is a positive number, any positive number, I just chose positive whole numbers, but or positive integers for that matter. But I could have chosen 5.6. I could have chosen any real number, any positive real number, and it would work. So that's true. So right now we can say that the square root of x to the 6 is going to equal x cubed for when x is when x is a positive number, positive real number. Okay. Now let's try 0. Let's see if it's true for 0. So the question is the square root of x to the 6 going to equal x cubed when x equals 0? That's the question. All right, so in place of x, I'm plugging 0. So I have the square root of 0 to the 6, and I want to see if that's going to equal 0 cubed. Well, you don't need your calculator for that. 0 to the 6 is 0, and the square root of 0 is equal to 0. And then 0 cubed is equal to 0 as well. So yes. So is the square root of x to the 6 equal to x cubed when x is 0? The answer is yes. All right. So far we know that this expression is going to equal this expression when x is positive and 0. So let's look at, is it going to be true if it's negative? So let's check the negative part. So the question is this now. Here's the question. So the question is the square root of x to the 6 going to equal x cubed? It's going to equal x cubed if x is negative, a negative real number. That's a question. All right. So suppose x is negative 2. Suppose x is negative 2. All right. So we're going to see if this expression, if this left side equals the right side. So we have the square root of, now I'm choosing negative 2. You could have chosen any negative number. It does not matter. Negative 2 to the 6, and I want to see if that's going to equal negative 2 to the third power. Right, so negative 2 to the 6, and I want to see if that's going to equal negative 2 to the third. Well, first of all, let's just see what negative 2 to the 6 is. So I need parentheses though. So parentheses, negative 2, close parentheses, and I'm raising it to the 6th power. So that's going to equal positive 64. Okay? And always remember, a negative number raised to an even power is always positive. So then I want to take the square root of 64. Well, I know that the square root of 64 is equal to 8. But if you look at this side right here, negative 2 to the third, negative 2 times negative 2 times negative 2, that is a negative 8. So those two are not equal. So the question is this expression equal to this expression when x is negative? And the answer is no. No, they're not equal. So if x is negative, the square root of x to the 6 does not equal x cubed. Okay? All right. Now we're going to come back to this in a little while. Now let's look at this one. So remember we were looking at this expression right here. We're looking at this. Okay. So let's look at this one. Let's simplify the square root of let's say x to the 10th power. Oops, I'm sorry. Let's say the 12th. X to the 12th power. That's a 12. All right, and we all know that the square root of x to the 12th, well, that's going to equal x to the 6. Okay, so the square root of x to the 12th is going to equal x to the 6. All right, so let's do the same thing. So the question is going to be, first question is this. Is the square root of x to the 12th going to equal x to the 6th if x is positive? Or remember, a positive real number. All right, so just pick a positive real number, any positive real number. All right, so if you want to say, well, suppose x is 4, let's say, you can. So now that's going to be a big number because this will be 4 to the 12th, so we're going to use our calculator for that one. So you're asking yourself, is the square root of 4 to the 12th the same as 4 to the 6th? That's what you're asking. So what I would do in the calculator is, see how you're taking the square root of this? And just do that. So and remember the square root is, to get to the square root, you're going to press the second x squared button. So second, let me clear this, second x squared, see how the square root symbol appeared with the parentheses? And you're going to say 4 raised to the 12th power, close the parentheses. That's how it looks, the square root of 4 to the 12th. Press equal, and you get 4,096. So that right here is 4,096. So let's see what this equals. 4 to the 6, 4 raised to the 6 equals 4,096. So if you do some more, you're going to see that's true. If you let x be 7.2, any real number, any positive real number, 8.95, you're going to see that this left side is going to equal the right side. So the question, is this expression, are those two expressions equal to each other if x is a positive real number? The answer is yes. Okay. Now do the same thing for 0. Remember, we're talking about positive real numbers, negative real numbers, and 0. So let's look at 0. So second question is this. Is the square root of x to the 12th going to equal x to the 6 if x is 0? That's your question. All right, well, you don't need a calculator for this one, but where we see it, the variable x, you're going to plug in 0. So you have 0 to the 12th, and is that equal to 0 to the 6th? Well, 0 to the 12th is 0, and the square root of 0 is going to equal 0. And 0 to the 6th means 0 times itself 6 times, which is going to equal 0 as well. All right, so the answer is yes. All right, third question, it becomes this. Here's your third question. Is the square root of x to the 12th going to equal x to the 6th if x is negative? Okay, if x is negative, is a negative real number. All right, and you can check it for any real number. We're just going to use one of them. So let's suppose x is negative 3, let's say. All right, so I have the square root of, put this in parentheses, negative 3 to the 12th. Since x is negative, go ahead and put in parentheses. And I want to see if that's going to equal negative 3 to the 6th. All right, in parentheses, put negative 3. So in your calculator, here's how you're going to do this. So you're going to say the square root. So remember to get the square root, second x squared. In parentheses, negative 3, close the parentheses, raise it to the 12th power, and then press equal. Well, you get an error. All right, so here's what we needed to do. We need to put 2 parentheses in there. So the square root, let's do it again, square root. All right, so basically you're going to have to, it's going to look like this. You're taking the square root in your calculator. All right, so whatever you put in, you're going to close it, but what you're putting in is a negative 3, so we need another set of parentheses like this, close it, and then raise it to the 12th power. So that's how you can enter it. So we need 2 parentheses and negative 3, negative 3, close that one, raise it to the 12th power, close at the end, and then press equal, you get 729. This right here is 729. Now over here, negative 3 to the 6, clear parentheses, negative 3, close the parentheses, raise it to the 6, and you get 729 as well. So the question, is this expression equal to this expression if x is negative? Is a negative real number? The answer is yes. All right, so let's kind of look at what we had here. So let's look at these two different things. All right, so if it's positive, remember for both of these right here, this and this. So in both cases, those two expressions were equal to each other when x is positive, always. When x is 0, always. But not always true if x is negative. This one was not true if x was negative. This one is true if x is negative. All right, so I want you to look at why this one wasn't true and why this one was. So let's go back right here, the very last one. Look at your, when you did the left side, that was positive, remember that? And then on the right side, it was negative. Look at your exponent. That exponent is cubed. If you have a negative number raised to an odd power, your value is going to be negative. So this is always going to be positive. This is always going to be positive right here. Now remember, we're assuming that x to the 6, your exponent is even. So you're assuming it's even. Okay, keep that in mind. So x to an even power, when I take the square root, all right, the square root of x to an even power, when you raise a negative number to an even power, it's always positive. When you take the square root of it, it's still positive. Okay, see that? When you raise a negative number to an even power, that value is positive. When you take the square root of that positive number, it's still positive. Here, when you raise a negative number to an odd power, it's going to be negative. Okay, so over here, when you raise, remember if x is negative, when you raise a negative number to an even power, it's going to be positive. When you take the square root of a positive number, it's still positive. When you raise a negative number to an even power, it's positive. So here's what you got to remember. Okay, whenever you take the even root of a variable raised to an even power, and we're talking about even powers here, if when you simplify it's odd, your exponent's odd, then you have to do something. If when you simplify the exponent is even, you're okay. You don't have to do anything. And then you're asking yourself, well, what is it that I've got to do? Well, here's what you got to do. Okay, so let's go back to this right here. This one. All right, listen again to what I'm about to say. You may need to go back and rewind this and review it again. All right, but listen to what I'm about to say. Okay, so question is this. Is the square root of x to the 6 going to equal x cubed if x is a negative real number? And remember, our answer was no. Okay? And it kind of makes sense now. Listen to what we said a while ago. It kind of makes sense because if x is negative, if I take a negative number raised to an even power, this radicand is positive. The radicand is positive. When I take the square root of a positive number, I get a positive number. Here, the right side, a negative number raised to an odd power is always negative, so a positive cannot equal a negative. All right, so here's what the next question is. Well, what do I need to do? What do I need to do in order for the square root of x to the 6 to equal x cubed if x is negative? All right, so what do I need to do in order for the square root of x to the 6 to equal x cubed if x is negative? Well, here's what you have to do. All right, now remember, this was negative 8, right? So what can I do to negative 8 to make it a positive 8? Well, remember 2 semesters ago when you talked about absolute value. So recall that the absolute value of a negative 8 is equal to a positive 8. The absolute value of a negative 4 is equal to a positive 4. Okay? So if I want these two sides here, if I want the right side and the left side expression to be equal, then I've got to make this one right here. I've got to take, because if x is negative, it's always going to be negative because you're raising a negative raised to an odd power. if it's raised to an even power, you don't have to worry about it because a negative number raised to an even power is always positive. But if it's raised to an odd power, you have to take the absolute value of that expression. So here's your answer. So what do I need to do in order for these two sides to be equal? If x is negative, you must take the absolute value of the expression, or maybe I should say of the simplified expression, of the expression that is simplified. All right, so the one that has the odd exponent. One has the odd exponent. So here's going to be your answer. So your answer is going to be, so the direction says assume that all variables can be any real number, positive, negative, or zero. So if it says simplify the square root of x to the 6, the answer will be x cubed with absolute value. Looks like this. Okay? So remember, you only say that if the direction says assume that all variables represent any real number. Okay? So let's look at some examples. Simplify each. Assume all variables represent any real number. So meaning positive, negative, or zero. All right, so listen carefully as we do this. Number one. All right, suppose we had the square root of x to the 20th power. X to the 20th power. All right, so our issue is not with a positive or a zero, because it's always going to be equal. We saw in both cases that if x is positive, those two sides will always be equal. If x is zero, those two sides will always be equal. But the issue is when it's negative. All right, so here's what you can think about. So the square root of x to the 20th we know is x to the 10th. So in your mind, think about, well, if x is negative, what happens? Well, a negative number raised to an even power is, so that radicand is going to be positive. The square root of a positive number is positive. A negative number raised to an even power is positive. So when I plug in a negative number, those two sides are positive. So we're okay. All right, so leave your answer like this. Don't put that in absolute value because that's going to imply that you really don't know when to use it. You must use the absolute value wherever it's actually needed. Don't put it everywhere. It's not correct if you put it everywhere. You got to know when to use it. All right, so that's the answer. All right, number two, what if you had the square root of x to the 30th power? X to the 30th power. Well, the square root of x to the 30th power, remember, is x to the 15th. Now, that will be the answer, guys, if the direction said assume that the variables represent non-negative real numbers, so meaning just positive and zero. But now we're saying what happens if it's also negative? Well, a negative number, look at your radicand here, a negative number raised to an even power is positive, so that radicand is positive. The square root of a positive number is still positive. But here, a negative number raised to an odd power is going to be negative. So you have a positive equal a negative. That's not true. So I need this to be in absolute value bars. Okay, so notice absolute value bars. Number three, the square root of 25, x to the, let's say, 24th power. Square root of 25, x to the 24th power. So when I simplified this, based on what we did in the previous lesson, that was just 5x to the 12th. All right? Okay, now, We're assuming that all the variables represent any real number. So all you really got to worry about is what happens if x is negative. Well, if x is negative, a negative number raised to an even power is positive. So that positive times this positive is still positive, and the square root of a positive number is positive. Over here, a negative number raised to the even power is positive. A positive times a positive is still positive. So we're good. You don't need absolute value bars here. Okay? Number 4. Suppose I had the square root of 49, x to the 18th power. X to the 18th power. Well, the square root of 49, x to the 18th power, we know is 7 x to the 9th power, to the 9th exponent. All right, so let's ask ourselves, do I need absolute value bars anywhere? Well, a negative number raised to an even power is always positive. A positive times 49 is still positive. Square root of a positive number is positive. A negative number raised to an odd power is negative. A negative times this positive is negative, so a positive cannot equal a negative. So I need absolute value bars. Now be careful. You remember the directions will say, make sure you put the absolute value bars wherever it is needed. So see, that 7 is already positive. That factor is positive, so you only need to put it with the factor that is negative. So that is positive. 7 is positive. What makes it negative is this right here, x to the 9th. So we got to put this. We have to put this x to the 9th in absolute value bars. So your answer, if we make it look a little bit better, will be 7 times the absolute value of x to the 9th. Okay? So don't say the absolute value is 7x to the 9th. Okay, that's not true, because the absolute value, because 7 is already positive. So if you say that, that's going to imply that you know some part, you know something about when to use it, but you don't know what to put inside of it. All right, so that's not correct. All right, this is a correct answer. So let's look at a couple more just to make sure you understand. Now, I don't recommend you looking at it this way. You see how when you simplify the square root, your exponent's even. You do not need absolute value. The exponent's odd. You did. The exponent, now that's only true for square root that I'm talking about. The exponent's even here. You did not need it. The exponent's odd here. You did. I want you to think about in your mind, what happens if x is negative? Just like we did. If x is negative, discuss it to yourself. If x is negative, a negative number raised to an even power is positive. The square root of a positive number is positive. A negative number raised to an even number is positive. So they're both positive, so I'm fine. I don't need it. All right, so that's the way you want to talk about it. All right, number 5. Suppose we had, let's see, suppose you had the square root of 100 x to the 50th power. 100x to the 50th power. So we all know that that's going to equal 10x to the 25th. All right, now you remember the directions say assume that it can be any real number, so it can be negative. So what do we need if it's negative? Well, this is odd. A negative number raised to an odd power is always negative. So this right here, a negative raised to an even power is positive, so that's going to be positive here. This is going to be negative, so I need to put this in absolute value bars. Okay? All right. Now, number 6. Suppose you had the cube root of x to the, let's say, 12th power. The cube root of x to the 12th power. All right, well, the cube root of x to the 12th power, that's going to be x to the 4th power. 12 divided by 3 is 4. All right, now, look what happens here. I want you to think about the process. Think about the process. If x is even, if x is negative, a negative number raised to an even power is positive. So my radicand's positive. If I take the cube root of a positive number, it's still positive. Right? If x is negative. If x is negative, this is still positive. And then a negative number raised to an even power is still positive. So I'm good. All right, what about this one? Let's do another cube root just to show you what's going to happen. What if I had the cube root of x to the, let's say, 9th power? Okay, and we all know that's going to equal x to the 3rd power. What happens if x is negative? If x is negative, well, a negative number raised to an odd power is negative. The cube root of a negative number is negative. That's going to be negative right here. Here, if x is negative, if I choose a negative number, let's say negative 3 for both cases, a negative 3 cubed is still going to be negative. So if x is negative, I don't need absolute value at all. So see how this was even, this was odd? And before, when we're dealing with square roots, if it was odd, I needed absolute value. For cube roots, it doesn't matter. It does not matter. So cube roots, if this is cube root, you're never going to need, you're not going to need absolute value bars. You're only going to need absolute value bars to use absolute value if the index is even. Okay, you will only need I'm not going to say need to use always. You will only need to use sometimes the absolute value bars if the index is even. If the index is odd, don't even worry about it. Now in this section, we're only going to focus on square root and cube root. So the cube root, you're not going to worry about. The even root, you will. Okay. So number 8. Suppose I had the cube root of, let's say, 8x to the, let's say, 30th power. All right. Well, cube root of 8x to the 30th power, that's going to be 2x to the 10th power. And so since it's cube root, I really don't have to worry about it. Now, if I want to think about it, I can. If x is negative, a negative raised to an even power is positive. A positive times a positive 8 is still positive. The cube root of this radicand is positive. A negative raised to an even power is positive. A positive times 2 is positive. So a positive equals a positive. So whatever that positive number is going to be the same here. All right, so we're good. 9, the square root of, let's say 81x to the, let's say 20, let's say 28, square root of 81x to the 28th. Well, that's going to equal 9x to the 14th. Again, I don't need it here because now square roots, I do need to check. A negative raised to even power is positive. A positive times a positive is positive. Square root of a positive number, whatever that number is, will be positive. This side is going to be the same exact positive number because a negative raised to even power is positive. A positive times positive number is still positive. 10, the square root of 81 x to the, let's say I wanted the 38th power. All right, so that's going to be 9x to the 19th. And so when I look at this, remember this is a square root, so it's an even root. So you got to check when you see an even root. So a negative number raised to an even power, see, a positive will always work. If x is any positive number, those two sides are equal regardless of every one of these. If it's 0, it's equal. If it's negative, that's where it's not always equal. Okay, so you got to check. A negative number raised to an even power is always going to be positive. A positive times a positive 81 is still positive. A square root of that positive radicand is positive. So whatever x is, it's going to be positive. This value is positive. Over here, whatever x value I chose, if I put it here, that negative number, that negative x, that negative number for x, raised to the power is negative. A negative times a positive 9 is negative, so that's going to be a positive value. This is going to be negative, and positive cannot equal negative. In fact, when you look at it, they're going to be opposites. So in order to make them the same, you need this to be absolute value bars. Okay? All right, and then finally 11. Let's suppose we had the cube root of, let's say 125 x to the, let's say 15th power. 15th power. All right, well, that's going to equal 5x to the 5th power. So remember, this is cube root. So think about cube root's not going to matter, because if x is negative, a negative raised to an odd power is negative. A negative times a positive is negative, and I can take the cube root of a negative number. It's going to be negative. Here, a negative raised to an odd power is negative. Negative times a positive number is still negative. So those, whatever negative value you plug into x, you're going to see that this side is going to be the same thing as this side. Okay? All right, now, one more thing we need to mention is this. If you look at your, well, don't even look at the calculator. I want you to think about, well, what is the square root of 25, let's say? Well, the square root of 25 we know is 5, because just like we did before, what squared is the radicand, so the answer is 5. But what if I had the square root of negative 25? Well, all right, now we're talking about real numbers. Remember, in this section, we're talking about real numbers only. So there is no number times itself that's going to be negative 25. You want the radicand. A negative 25 because whatever number you put in, whether it's positive or negative, and you multiply by itself, it's going to be a positive number. So in this section, and on MyMathLab, one of the choices in some of the problems will say not a real number. So the square root of 25 is a real number. It's 5. The square root of negative 25, if you look at your calculator, just look at your calculator, just put in square root of negative 25. So you get an error. Oh, sorry. Let me do it again. Square root of negative 25 equal, you get an error. So that means the square root of negative 25 is not a real number. Now, in another section, we're going to talk about imaginary numbers, and so that's where that's going to come into play. But in terms of a real number, the square root of negative 25 is not, you're not going to get a real number back. Okay? All right, so this was a long video, but quite a bit of it was taken up by the explanation of why would you need an absolute value and why would you not.